Okay, this is problem number 2 on page 9 in your lectures. So we are given here a circuit, and then it involves dependent sources. So we have a dependent source here, 3 times Is. That means its value is dependent upon the value of this Is. Okay, so we are going to look for VO. The VO is the voltage across 3 ohms. So if you know IO, 3 times IO is just the VO. And then we're asked also to perform power check, or find or determine whether total power absorbed equals total power delivered. So this is still part of KCL KVL. So let us determine the loops and the nodes. So I cannot see any significant node here. So we're just going to perform KVL on this loop. This is a complete path, and this is also another complete path. So we have two loops. So since VO is the one we're looking for, so let us start with the equation here, and then let us get the value of VO. So we know that VO equals 3 times IO. So we need to get the value of IO. Okay, so since we are going to perform KVL here, we need the value of IS. Let us try to perform KVL here because IS is here. So we're going to have our first loop. Let us call that loop number 1. And then let's start with 10 volts. So we have negative 10. And then plus. Of course, this should be plus and minus. So since current is entering the terminal, it's supposed to enter the positive terminal of 6 ohms because it absorbs power. So 6 times, what is its current? Is. So this equates to 0. We can now get the value of Is. Is therefore equals 10 over 3, or 10 over 6, or 5 over 3 amperes. Okay, and then we perform to get VO or IO. We perform another KVL here. So this is now loop 2. Now let's start with the dependent source. So this is, KVL at loop 1. So let us perform KVL at loop 2. Let's start with this. So negative 3, it's the value of the voltage here is negative 3 times the value of Is is 5 over 3. And then since these two resistors are in series, we can combine them as 5. So plus 5, and the current through them is IO. So equals 0. So therefore, we can now get the value of IO here. Cancel the 3. And then transpose to the other side. So we have 5 divided by 5 is 1 ampere. Therefore, we can now get the value of VO. VO is 3. The value of VO is the voltage across 3 ohms is 3 times its current. So 3 times IO. But what is IO? 1. Therefore, we have 3 volts. So we have gotten the value of VO already. Now let us perform power check. So let us first get the power at delivered by 10 volts. Power of 10 volts. Where's that? What is its voltage? 10. What is the current flowing through it? Of course, our Is. Our Is is just gonna flow in complete cycle. Okay, so 10, the voltage is 10, and the current is Is, which is 5 over 3. So the answer now is 20 over 3 is. And then let us get the power dissipated by the 6 ohms. 6 ohm resistor, this one. So I squared R, what is its current? Is. So this is 5 over 3 squared times 6. So this is 6 divided by, let's just calculate. 25 times 6 divided by 9. 16.66, or in, this is 50 over 3 in fraction. So this is in watts, this is delivering, and this is watts, this is absorbing. Another one is the 3is. So power delivered or absorbed by 3is. 3is is the dependent source, this one. So its voltage is 3is and its current is IO. Therefore, what is its voltage again? 3is, so 3. What is is? 5 over 3. And then what is its current? IO is 1. Therefore, the answer is 5 watts. And it is delivering. And then the last, the power of 2 and 3. So let us just power of 5 ohms. This is 2 plus 3 ohms. What is their current? IO, and IO is 1. So 1 squared times 2 plus 3, 5. So the answer is 5 watts. And this is absorbing. Okay, so let us now determine whether power absorbed equals power delivered, or power delivered equals power absorbed. So what components delivered power? These two, this one, 3 and this one, yes. So 20 over 3 plus 5, 20 over 3 plus 5, the answer is 35 over 3. And then power absorbed, 50 over 3 plus 5. I am sorry, this is also 50 over 3. I'm sorry, 50 over 3. 10 times 5 divided by 3 is 50 over 3. So this is absorbing is 50 over 3. 50 over 3 plus 5 also, and that is 35 over 3. So they are equal. So we have satisfied the power check. That means our answers are correct.